Hello students, and welcome to the week 10 example video. So this will be the last example video for this year's Excel course. We will probably through the year still upload a few videos, perhaps a bit more shorter content on a few of the NX features and so on, so that you can continue practicing and preparing for first year next year. So keep an eye out for that. But for now, let's get started with this assembly. So for this week, we're going to be making this arbor press. So it's a bunch of parts, looks quite complex, but actually it is very simple. So let's get started. I already created the assembly, so I'm going to pull in all my components real quick. So add component, then I'm going to say open, and it's already in the correct. Now this is the homework, so let's go to the lesson example. There we go. So here are all the parts. Obviously, this is the assembly that we have open at the moment. So I'm going to select all of these and say, okay. There we go. So it has pulled all of them in here, but it hasn't actually added anyone here yet. So the reason is because I have different quantities of each that I want to add. Okay, so let's first select the ones that I want to add one of each for. So I basically need to unselect the nut, Allen screw, and the hex bolt. Okay, so let's quickly see the nut. I want to unselect that. So I'm holding in Control and then I'm clicking it. So the hex bolt, and I think it was the Allen screw. Here we go. So for the rest, I want one, and then select location. So it's just automatically adding it all where it feels like. So I'm just going to say, okay, I'm just going to click. So let's see if it will snap to that. It doesn't. Okay, I'm just gonna click there, say okay, lovely. So now for the nut and the hex bolt, the nut and the Allen screw, I need to add two of each. So add component. So let's say the Allen screw and the nut over here, I need to add two of each. So I'm going to add them over here, and I'm just going to say apply, and then I'm going to add the hex bolt. So where's that? Here we go, hex bolt. I need to add four of them. So my location, just going to add them over here. Okay, there we go. Now I have all my components added. So if you have a very large assembly, I recommend adding the parts as you go along with it. And if you have a very complex assembly, consider sub-assemblies. But for this one, it's still simple enough so that you can get away with just adding it all in one go and then going from there. So some of you had questions about anchoring the base to a certain position relative to the origin. So for assemblies, like I said, it's not that important because you have a fixed base and you work from that. But for those of you who want to, you can do it. So you can go to Home, click here, say datum coordinate system, and it will automatically try to add it where the work coordinate system currently is. Let me quickly show you. So over here, so if you click W, this will appear and disappear. So it will automatically want to add it over there. So you can just say okay. And then you can move, or even if you want to constrain this to that. So let's say you want to align the base to this plane, the other way around, the one that makes more sense. You apply, and then let's say I want to add this center line to, let's right click, select from list the Z axis. So it yells at one another because it wants to turn it around. So just other way. There we go. It says it has errors, but I checked and it doesn't have any errors. I don't know why it has a problem. But yeah, now this is fixed. Let's try to move it. And it might actually rotate. Yes, it might rotate. So let's quickly just constrain that. So we can just say parallel. So this to that. Okay, there we go. Now it shouldn't be able to move. So let's see. Yank it up and down, side to side, backwards, rotate, rotate, rotate. No. Okay. So now it's fixed in place. So you can do that if you want to, or let me just unconstrain that. Alternatively, you can say this thing should be fixed. and then it will say fixed, and yeah. So to each his own. Okay, so the next part I'm going to put in place is the arm over here, or the L bar as it is named. So for this one, part of creating assemblies is you have to use your intuition. So from the sketch, it appears like it should be, the bottom of this should be aligned with the bottom of the base. So, and you can also see it's open here, and that makes logical sense. My apologies. So obviously if it's your own assembly, you'll be able to know exactly what you want. But if it's someone else's parts, you need to infer some of it, but that makes sense. So unless something else shows you the contrary, use your common sense. Okay, so I'm going to say first I want to center. I want to go 2 to 2. So I want to center this within that. So I'm going to say those two, centered with those two, and there we go. It's centered, but now it's clipping. So that's fine. We'll just move it back. So the reason I used center and not align, just aligning one of the sides, is sorry, keep changes. For this part, let's quickly check. This distance, which is 80 millimeters, should be the same as this distance. Yes, but in the real world, you have tolerances. So this one will be a bit larger than this one. So then if you create an assembly that has parts which have tolerances, then you use center to just make it a bit more neat and make it line up theoretically perfectly. So you don't already give it misalign it when you have the option of doing it correctly. Okay, so then assembly. So now I want to align this face to this, not that way. So let's do that. There we go. Now that is correct. So it's already lined up with the bottom now, but it's not constrained that way. Let's quickly check that. There you go. So you also want, I'm just going to say, okay, you want that aligned. So if you didn't explicitly tell it to be in a place, try to move it around, see if it moves. And if it moves in a way you don't want, then constrain it. So align that. There we go. Now it is in place. Okay. So next, let's quickly see. We have a few options. So I think first I'm going to add this base. Let's quickly see. Yes, the circle base. So that's also the third one in this assembly drawing. So first I'm going to align these centers, because as you can see, it goes into that this pin and this whole interfaces, so that it should be clear from this, but if it's not clear, it makes logical sense. Okay, so select that, and you will see I made this the motion object and this one the stationary one. It doesn't matter, because this is fixed, it will stay in place and this one will move to it. NX is smart enough to realize that. So select it, it's upside down, other way around, there we go. It's within the other part, so let's just select it and move it up. Okay, so now this larger cutout should align with this. As you can see here, the larger cutout is on this side. So for this, I'm also not going to, because I think theoretically these center lines should align, but that's not a way that you can actually, you're not going to look at two circles and be like, yes, these center lines are lining up. That's not practical. So I'm going to say again, center, and then I'm first going to move it closer to where I want it to be. So let's just rotate it a little bit. There we go. And then center, 2 to 2. So this one and this one aligned to this one, or sorry, centered to this one and this one. There we go. Wonderful. Okay. And here we can see it's flush with this bottom. So just align this and this one. It shouts at me, other way around. There we go. So like I said earlier, NX is smart enough to do some stuff, and then sometimes it wants to do stupid stuff. So you'll just have to roll with the punches. Okay, so that's now nice in place. So now I'm first going to assemble this part to the gear over here. So in the real world, you put the gear inside and then you'll put this in and you'll add this key. So as you can see, this gear fits inside of that. And this slot is so that when this is in, this key can be, or this key can come in with this and be fastened. However, you don't have to do it that way in NX because it's difficult to see inside. So you can just do it outside first and just move it in afterwards. Okay, just to make life easy for yourself. And that may be the reason why people who actually have to manufacture things that engineers create hate engineers, because we don't always take into account that they actually have to fit their hands inside of parts and create them. But that's a thing that we can figure out later. Okay, so first I'm going to just place this closer to where I want it. So I'm going to move it this way. Okay, it's a bit too far. Yeah, and then I'm going to rotate it like this, 90 degrees, rotate it this way. Okay, so now it's close to where I want it. So I'm just going to align its center line to this center line. And I want it the other way around because this hole is for the handle. So that's good. So now I can say, okay, I want this gear to have its center line aligned with this, and it is symmetrical, so it doesn't really matter which side I place it. So that's fine. Now it might struggle because I want to rotate this gear. I don't want this to rotate. I imagine this guy is going to rotate. Yes. Okay. Wonderful. So let's just cancel that now. Discard changes. So I'm first going to just fix this one in place. It's going to yell at me. It's fine. It's actually not yelling at me. Whatever. I just want it to stay in place while I rotate this. That is because I want this key slot to be aligned with this key slot, or be close to it, so that when I align it, it aligns on the right side and not on the wrong side. Okay, so let's do that. So 2 to 2. So this, oh dear, it's gone. There we go. And this should be centered with this and this. There we go. Okay, and let's get rid of this fixed constraint before I forget it exists, because otherwise I want to move it and then it doesn't want to move and I get angry. Okay, so now we also want this key. So you can see this key should interface here and there. So I'm going to, again, center it. So this is just a little piece of metal, so it's completely symmetrical and so on. So it doesn't really matter how I select it. So we can just use 2 to 2 again. Those two faces should be aligned with this face and come now, and this face, and it should be fine. Yeah, it's a bit weird, but it's fine. And then I can, let's just move it a bit closer so that I can actually see what's going on with the thing. Okay, it did rotate it weird now, so let's just move it over here. There we go, it's basically where I want it. Nope, it's a bit far down there. Let's just move it a bit closer. Okay, that's very weird. But whatever. Okay, now it's close enough for me to actually be able to look at it. So now let's just align two of these faces. So I'm going to use the top face. Make sure you don't select the edge, but the face. And align it with this one. And now I first need to check that I have it the right way around, so that the bottom is not, yeah, you see it's aligning this to this, and now it's on the inside, so I want it the other way around. There we go, that should be correct. Okay, so let's say that should now be centered with that key hole, or key slot rather. So 2 to 2, so I'm using those two, and then I'm using these arc circles, or arc center lines, and there we go, it's in place. And then I'm going to use that to constrain this. So this side and this side to this side and this side. There we are. Now it's nice in place. Okay. So now that entire thing must go inside of there. So as you can see, in the real world, you first put the gear in there, and then you'll put the key inside of the slot and essentially just hammer it into place. Or rather gently tap, because I don't want to break the thing. But yeah. Okay, so now we can actually go place this inside. So again, I'm going to use center because it's going to fit perfectly for this. But if you have tolerances, then you want to have everything nice and lined up. So these two with this face and this face, and there we go. It's in place. So now I want to add this little, I think theoretically, brass probably, whatever. I want to add this little press sleeve here, and that should be kept in place with the other pin that I forgot to move out of the way. So what's its name going to be? Yeah, 11, it is, yeah, just press pin. So where is that? There we go, the pin. Well, I cannot see it, so I'm just going to leave it selected and say move component. There we go, it's inside of the base at the moment. There we go, just move that out of the base. There we are. Okay, so now I'm going to say line. So you might have noticed, like I said in the first assembly, 90% of what you do in assemblies is just aligning center lines to one another, because usually things are connected with circular components such as screws and bolts, and you have axles and pins and everything. So that's the tool you will use the most. So just align those center lines. That's good. This part is symmetrical, so it doesn't matter which way around. I'm going to say OK. And then, yes, so these holes should be aligned with this hole that is through the part. There you can see. So I'm going to say OK. Take this one and align this hole with this hole. You can use concentric, but I prefer to use the align axes. It just works better for me. Okay, so that one's fine. Now I need to add this one into that, this pin into that hole, because it should be kept in place. It won't just be held in place by fairy dust as it is in NX. So align, center line to this one, and where is it now? It's over there. Okay, and then I'm going to center it. So this time I'm going to use 2 to 1. So I'm going to use either side of this, and I can use this center line, or I can even use this face. It should work. So let's see. There we go. It's centered. And let's see it from this side. There we go. Perfect. Okay. So now it's just the last finishing touches, such as functional components. So that it's added in there, and it should be in that slot. There we go. So let's first move it a bit closer. As fun as it is to see NX moving the parts around, sometimes it's just a bit more practical to put it in roughly the correct position first. Okay, so 180 degrees and 90 degrees. So, oops. So take note of this trapezium-ish top, and that's what should be on top over here, because the hole at the bottom, that one, is for this to interface with. Okay, so now, again, I'm going to use center and not align, because tolerances. So those two, oops, had it on the incorrect setting. It's Control Z, undo that one, and it undid the move as well. Wonderful. Let's move it again. Put it over here, rotate it 90 degrees, rotate it 180 degrees. There we go. Okay. Save. And then center, and I want to center 2 to 2. So this one, and this one to this one, and this one. Okay. And then I'm going to align the back of this to this. There we go. And that is correct. Yes. So in the real world, you will also have, let me just move this up a bit. So you see these are flush, and then you have this plate. So in the real world, you will have a wear plate in here. But this assembly is a bit simplified to just not add too many stuff for you. So that was left out, but just keep that in mind. So for now, this is just a symmetrical block with holes in it, so which we can then also move in place. So let's select it, slide it over here, slide it this way, rotate it 90 degrees. Oops, there we go. Up, closer. Yeah, it's close enough. And now again, I'm going to align the holes. So I like to use the ones at the corners. No, that's a weird way of doing it. There we go. Apply. And then use these ones the way around. There we go. Now it is in place. And now I just need to connect it to that side. So I'm going to use align. So this face, the way around. There we go. Now it is in place. Now I just need to add the screws to it. So for simplicity's sake, or for speed rather, I'm just first going to align these bolts to be in the same plane. You'll see what I mean in a moment. So I'm going to say this bolt and this bolt, apply this bolt, and this bolt, apply this bolt, and this bolt, apply. So essentially, I don't need to, in air quotes, screw each one of them in. I can just screw one in and it will be good. So I just need to align the center lines with the holes. So let's say this one first. It's way over there and I want it the other way around. So there we go, apply. Okay, I haven't looked at this in a while. So that is these screws that go in here. Okay. You can also just add, probably should have said this earlier, but you should just have this open for yourselves if you are wondering where I'm getting my information. So I did this in class. So for my class, this should be familiar. For the Afrikaans and double medium class, this is probably the first time you're looking at this part. So yeah, just have this open for yourselves. Okay, so now I can just move this to the correct side of the part. So you see, as I move one, it moves all of them because they are all in the same plane, or at least these faces are in the same plane. Okay, so that one is lined up. So now I can just align the other ones as well. So this one I can align with this hole, the other way around, apply, and this one to this hole, the other way around, apply, and these ones. You would think with the fourth one NX would know it's the other way around, but apparently not. There we go. And now I just need to align this face to one of them because they're all aligned to one another, and again the other way around. There we go. They are all screwed in. This plate is now in place. Okay, so now I can quickly add this to the screw over there, not screw, to the straight gear. So I'm going to say align, again this one to this, and it turned it around, so that this time it worked out. Apply, and now I just need to align this face with this face. So theoretically you could use this one with the inside, but with tolerances this will be made a bit shorter than the hole so that they don't interfere. So that's why I'm doing it this way around. And yes, NX the other way around. There we go. Okay, so now I just need to add these and this one. So theoretically these will be connected to this plate over here, and then these screws go through them and then press against this, well, rather against the wear plate, which is between them and this, and then that can also keep it in place, or yeah, basically it will keep it in place. Right, so let's quickly first align these screws. So difference between a bolt and a screw, it's, well, if it has this kind of hex like a Allen key interface, that's a screw, or if it's a Phillips head or flathead, those are all screws. And if it's like this, it's a bolt, but it's all arbitrary. It's all, in my opinion, the same. So let's just align these faces. So this one and this one, lovely. And I'm going to also align these two ones, and then I can also align these ones. Apply this one to this one, apply. And then I can take this and align that to this, and it's wrong the wrong way around. So this side, there we go, apply, and these ones over here, it's yelling at me, other way around, there we go, apply. So then I can say this one, other way around, apply. And then, so you will notice these screws stick out a little bit because, like I said, they are meant to screw in and then press against this. So now I can't say, okay, these faces should be aligned with that, but rather this face and that one as well should be aligned with, well, with this, because there's nothing in between them. And yes, the other way around. There we go. And it says it has errors, but it has no errors. You can see there are no warnings, there are no errors, it's fine. Sometimes NX gaslights itself. Okay, and the last thing we need to add is this. So for the English class, you know, we had a bit of trouble centering it around this hole. So I found a solution. It involves not centering it, but we'll get to that. So first, let's align this to, let's see, yes, to this center line. Now that's fine. Okay, and then I'm going to first just move it roughly into place. Okay, so in class I try to use the center and the 1 to 2 or the 2 to 1. It's the same thing. So I wanted to say, okay, I want to align, let's say this one or this one. Doesn't really matter to these two, but for this one, it can't select the spheres. It can select the center lines. And if you want to say, oh, but I can select this ring here, no, it's the center line still. If you look closely, if it will select it, let's just move it around. Now it doesn't want to select them at all. But in any case, so yeah, that was a problem. So I can select just the sphere for the single one. But yeah, so what you have to do with that one is you have to add a distance constraint. So first, you can go to analysis. So you can go to analysis here and measure, or you can go to analysis here and measure. Same difference. So you can measure from this ring or the edge and go to this one. And that's a distance of 290 millimeters. So you can just right click on this, copy. And then I also saw many of you typing things into your calculators during the tests. Remember, NX can do math. So type in whatever you want your distance to be. If it's an equation, just type it into the box and it will calculate it itself. And yeah, so there can't come any human errors in there. Well, there is less opportunity for human errors. Let's put it that way. So that is copied now. Okay. So now I can just add a distance constraint over here and say, okay, this edge and this center line should be based. So Control V, the 290, the 2 is just cut off. So let's just go this way, 290, point all these zeros. I'm just going to get rid of them, divided by 2, because half of it. Enter, you see they did the math, and now it is beautifully centered. So if I want to measure, I can measure from this side to that center line, and that is 145.3452. Why it's supposed to be the same, don't know. But yeah, 0.3 millimeters is not going to change anything, because in the real world, this just slides willy-nilly, so it doesn't matter. Let's see if I measure the other side, because I did measure from here to Yeah, doesn't matter, inconsequential. So, but now we can still move stuff around. So if I want to start yanking at things, so this guy, it can move up and down. It shouldn't be able to rotate or anything. Well, if I rotate it, it moves up and down, but that's whatever. And this can still rotate. So which handle? There we go, this handle. So if we quickly cancel this, score changes. If we add a section or a clip section on this face, lovely. So now you can see currently, well, actually currently they are meshing quite well. So let's quickly go over here to move component. The thing is, if I want to, let's say, take this guy and rotate it, it's just clipping through. So that's not what we want. But to add motion simulations now, it's a bit beyond the scope of this course. So I'm just going to discard this, and I'm going to work on predefined dimensions that will make sure this works out. So that is this distance and this angle. So 108.15 millimeters from the very top to this face. Sorry, that was 108.15. So from here to here, it's 108.15. You can obviously add a lower limit and an upper limit. You can do that in your spare time. And then we want an angle of 35 degrees between the center line and the stop. So this to this should be 35 degrees. Okay, it's adding it over here instead of over here, but you should know from math that if you have two straight lines on either side, the angle is the same. So that should make sense. So if it's let's look at this. Let's just say okay first. So yeah, let's look from the right side. For this one and this one, obviously 90 degrees, 90 degrees. And if you move this all the way down, 0, 0, so necessarily they're going to be, and if it's 45, it's also 45. It's, yeah, so, but you should know that from math. Okay, so now everything should be constrained. So if I try to move anything, it's all stuck in place. So this thing is moving around, but it's not actually moving the part. So just cancel that. And if we turn clip section on again, and we go over here, sorry, wrong one, go over here, you see, it's meshing beautifully. Well, they're not touching, but they're nice. They're not clipping through one another, so that's fine. Yeah, and that is the whole assembly. Let's just unclip it, and we can go over here and say, sorry, control, cancel. I want to go to show and hide assembly constraints. There we go, nice and pretty. I also want to hide the coordinate system. I can just click W and hide that. There we go. Now it looks nice and pretty, and it's all assembled. So yeah, looks quite complex, actually quite simple. It takes a minute to do because there's a lot of parts, but yeah, it's not difficult at all. Okay, so hope you guys try this one, practice it. So obviously you won't be assessed on this, but you will need this to do assemblies for the project. So yeah, and then so for the homework, it's going to be a ball valve. But yeah, you will see that on your Fundi. So yeah, enjoy the rest of your week, and good luck with the homework. Cheers.